Hello pre-calc students, and welcome to the video introducing exponential functions. We're going to learn how to evaluate exponential functions in this video, a little bit about them, and how to find their equations. All right, so let's first talk about identifying exponential functions. When the independent variable, which is what we usually refer to as x, is in the exponent, all right, let's learn how to identify exponential functions. When the independent variable, which we usually use x for, is in the exponent, that's considered an exponential function. So let's look at these example functions down here and decide which of these are exponential functions and which ones aren't. So for f of t, the first one, f of t equals 56 to the t. That is an exponential function because we can see the variable up here in the exponent. Looking at g of v equals 56 v minus 1 to the 3, we actually have a constant, a 3 in the exponent, so that is not an exponential function. H of x equals e to the x is, because e is just a number, we're going to work on e in this section, and x is in the exponent, so yes. And finally, t of n equals n to the 1/7 is not, because 1/7 is in the exponent, not the n. So the general form of an exponential function is f of x equals a times b to the x. I'm going to take just a minute right now to talk a little bit about linear functions. It really isn't considered a topic of 111Z. It's considered a prerequisite topic, but lots of times people just need a little bit of a reminder about what those are about. So I'm going to talk about it really quickly here. So remember, linear functions are the form mx plus b. M is the slope, which tells you how the function changes, and b is your vertical intercept or y-intercept, and this tells you sort of where the function starts at time 0. It tells you where it crosses the y-axis. For example, if we had a linear function, f of x equals 2x plus 1, the slope is 2, which means that it rises 2 for a run of 1, right? So every time the x increases by 1, the output increases by 2. And we also know that at time 0, when x was equal to 0, the output was 1. So that means 1 was our initial or our starting value. Just a quick reminder about linear functions. All right, the general form of an exponential function is f of x equals a times b to the x. And the a represents your starting amount. So if we plug in 0 for x, f of 0, at time 0, or starting place 0, we would get a times b to the 0. Now, remembering our order of operations, we do exponents first. The 0 is only on the b, so we just take b to the 0th power, which is 1. So that's a times 1, which is a. So that makes sense that a is always going to be your starting value, because when the independent variable is equal to 0, you're just going to get a out of the function. B represents the change. And in this case, it's a percent change. So that can be either growth or decay. So percent change means that these exponential functions are changing by a fixed percent every time, unlike with linear functions, which are changing by a fixed amount. If the exponential growth b, if b is greater than 1, we're going to get an increase in exponential growth. And if b is less, between 0 and 1, we're going to get exponential decay, which means that it's going to decrease in the original, take a percent decrease of the original amount. All right, so let's jump in and investigate an exponential function from a table. I think I said all this stuff already. Yeah, linears change by a fixed amount. Exponentials change by a fixed percent. All right, so here in this table is an exponential function. We're going to find an equation for it of the form a times b to the x. So what that means is we need to find the value of a and the value of b. Remember, a is the starting point and b is the percent change. Well, the starting point is the easiest place to start with, because we have right in the table that at x equal to 0, f of x equals 9. So this tells us right off that a is equal to 9. All right, so now we know that f of x equals 9 times b to the x. We have part of it figured out. And now we need to figure out the percent change. So the way we're going to do that is we're going to look at the ratio. Oh my goodness, what am I doing today? The ratio of previous values next values to previous values. So what do I mean by that? I wish I hadn't drawn this arrow. I mean that if we look at starting at 3 to 9, if we look at the ratio of 9 to 3, that is equal to 3. And if we look at the ratio of 9 to 27, 27 over 9 is 3. 81 over 27 is 3. And 243 over 81 is 3. So the output is tripling each time. This tells us that the b value is this constant percent change, which is 3. So our function is f of x equals 9 times 3 to the x. And we can check this with any of the values. Let's go ahead and plug in 2 just to check. So f of 2 equals 9 times 3 to the 2, which is equal to 9 times 9, which is equal to 81. So that checks out. All right, so that's found our first exponential function. All right, let's try and find an exponential function from a graph. So here's a graph of our exponential function. Again, this is also an increasing function. We can see as the graph goes up from left to right. And let's go ahead and do the same sort of process. First find A and then find B. Well, we can't read it off the table, but we can read it right off the graph that at x equals 0, f of x equals 2. So that tells us that A equals 2. So now we know that our function is f of x equals A times 2 to the x. All right, let's look at a couple other values. Well, at 1, the output is 4. And at -1, the output is 1. So we have some previous and next values. We can make a little chart. At -1, it's 1. At 0, it's 2. At 1, it's 4. This is enough. We look at 2 to 1, and that's 2. We look at 4 to 2, also 2. So we know that our b value is equal to 2. So our function is f of x equals 2 times 2 to the x. All right, so that's the basics of finding the equation of an exponential function. All right, our next example is to find the exponential equation between 2 points that are given to us. The points that are given to us are 0, 8, and 3, 1. We're going to find both the exponential and the linear function. So let's start with the exponential. We know that we have the points 0, 8, and 3, 1. Let's go ahead and plug in the 0, 8 value. Our model is a times b to the x. So if we put in x equals 0, f of x equals 8, well, we know that a is going to be equal to 8, but let's go ahead and plug it in just for fun. 8 equals a times b to the 0, which is just a, so that tells us that a equals 8. So now we have f of x equals 8 times something to the x. We're going to plug in our second point, which is 3, 1. So 1 is our output equals 8 times our value b to the third power. All right, we need to solve this one since we aren't given consecutive values. Oh my goodness, why do I keep doing that today? All right, so we need to solve this for b. Really what we're looking at is the equation 1 equals 8 times b cubed. So let's divide both sides by 8 first. So 1/8 equals b cubed. We solve that by taking a cube root. And that tells us b equals the cube root of 1/8. Well, what time itself 3 times is 1/8, and that's going to be 1/2. We can also think about this. Remember, cube roots work that you can do the numerators and denominators separately. So the cube root of 1 over the cube root of 8 is 1/2. So our function is going to be equal to, oops, that's not what I meant to do. F of x equals 8 times 1/3 to the x. So that's our exponential function that goes through those 2 points. So again, when you're solving for the equations of exponential functions, you always find the a value first and the b value second. All right, let's go ahead and just as a quick review, what if we were asked through the linear equation between these 2 points? Again, this isn't a pre-calc topic, but I do think that lots of times people need a review on this. Remember, for that, we're looking for a function of the form f of x equals mx plus b. And when we're solving for linear equations, the first thing you do is always find the slope. So our slope m is going to be, remember this is y2 minus y1 over x2 minus x1. So that's equal to 1 minus 0 over, 1 minus 8. I looked at the wrong value there. 1 minus 8 over 3 minus 0. So that's negative 7 over 3. So that's our slope. So now we have f of x equals minus 7/3 x plus b. So now we find our b value. Plugging in either of the 2 points. Let's plug in the 0, 8, because that's certainly going to be easier. 8 equals minus 7/3 times 0 plus b. So that tells us that b is equal to 8. And that our linear equation would be f of x equals minus 7/3 x plus 8. Now, if finding this linear equation did not seem at all familiar to you and you don't remember it all, I really encourage you to contact me or even look in the helpful videos section of our Canvas page, and there will be other videos reminding you how to find the equation of find the linear equations. All right, that is all for this video.